Hi, I'm Dr. Yu-Ling Lee, an education professor. Let's look at how astronauts teach and learn. Learning for astronauts begin with an aspect of space travel that might seem surprising: survival. Long before they step onto a rocket, astronauts undergo a curriculum of intensive survival training to prepare for every conceivable emergency. In survival training, astronauts don't just sit in a classroom or read manuals. They dive right in, practicing in real-world environments that mimic the stress of an emergency. Imagine swimming 3 lengths of a 25-meter pool. Now imagine doing that in a bulky flight suit and heavy boots. Then, after that, treading water for 10 minutes without rest. These physical demanding tasks push astronauts to their limit, building both endurance and mental fortitude. Take the example of NASA's Apollo 11 mission. Neil Armstrong, Buzz Aldrin, and Michael Collins had to be ready for a splashdown in the Pacific Ocean after their historic moon landing. So part of their preparation involved water survival training, ensuring they were ready for a safe recovery by US Navy teams in the middle of the ocean. To prepare for this challenging task of working in zero gravity, astronauts rely on immersive simulations. For astronauts, moving and performing tasks in outer space is not something you can just pick up. It requires intense, specialized training. So NASA uses 2 key methods to teach astronauts how to function in this weightless environment: parabolic flights and the neutral buoyancy laboratory. Parabolic flights, often called the vomit comet, involves flying a specially designed aircraft on a roller coaster-like trajectory that creates brief periods of weightlessness, about 20 to 30 seconds at a time. During these fleeting moments, astronauts float just like they would in space, practicing movements and handling equipment. But the core microgravity training happens at NASA's Neutral Buoyancy Lab. It's a massive 6.2 million gallon water tank. Astronauts practice spacewalks fully suited as if they were already out in the vacuum of space. Submerged in water, they experience a sensation similar to floating in zero gravity, allowing them to practice tasks like repairing satellites, maintaining the space station, or even constructing parts of a spacecraft. But this is more than just a physical challenge, it's a mental exercise as well. In an environment that feels completely alien, astronauts must learn how to move gracefully, coordinate their actions, and operate tools with precision, all while wearing bulky spacesuits that restrict their movement. The weightlessness combines with the suit's limitations, forces them to develop a new sense of coordination. One amazing example comes from the astronaut Chris Hadfield, the first Canadian to command the International Space Station. Hadfield spoke about how critical the Neutral Buoyancy Lab training was for his first spacewalk. During the training, he spent hours underwater simulating the intricate tasks he would later perform in space. He recalled how the practice made all the difference when he had to repair the ISS Canadarm2, a robotic arm essential for station operations. In space, being a self-learner is essential. When astronauts are hundreds of miles above Earth, communication delays can make real-time guidance from mission control impossible. This is why astronauts train extensively to troubleshoot problems on their own, becoming independent problem solvers capable of managing any situation. One of the most complex aspects of astronaut training involves learning to operate and maintain spacecraft systems. So astronauts spend countless hours in simulators, studying the inner workings of everything from life support systems to navigation controls. They don't just learn the basics, they dive deep, developing a comprehensive understanding of how each system works, what could go wrong, and how to fix it. For example, during the Apollo 13 mission, astronauts Jim Lovell, Jack Swigert, and Fred Hayes faced a life-threatening problem when an oxygen tank exploded and crippled their spacecraft. With limited guidance from mission control, they had to work autonomously to manage their life support and electrical systems in the lunar module, which had been designed for short-term use on the moon, not to sustain 3 astronauts for the return trip to Earth. The level of self-learning is compared to a flipped classroom in space. Astronauts first learn theory, how the system works, possible malfunctions, repair protocols. But when they're in space, they have to apply the knowledge under pressure, making critical decisions in real time. It's not just about memorizing content, it's about understanding how to think on your feet when there's no immediate help available and applying your knowledge. An excellent example of this is astronaut Scott Kelly's year-long mission aboard the International Space Station. During his time in space, Kelly and his crew had to perform numerous repairs and troubleshoot equipment malfunctions, all while managing the physical and psychological demands of long-term isolation. Kelly often spoke about how critical their self-learning was, particularly when facing unexpected challenges like air leak or equipment failures. The training they received allowed them to act swiftly and effectively, even when mission control wasn't immediately accessible. Long-duration space missions, like those aboard the International Space Station, brings not only physical challenges, but also profound mental ones. This isolation tests their psychological resilience, pushing them to develop strategies that help them thrive in these extreme conditions. One of the key frameworks used in psychological training is rooted in the concept of growth mindset. Psychologist Carol Dweck's research shows that individuals with a growth mindset, those who believe their abilities can improve through effort and learning, are better equipped to handle challenges, setbacks, and stress. For astronauts, adopting this mindset is essential. They must see every challenge as an opportunity to learn, adapt, and grow. Astronauts must not only rely on their technical training, but also their ability to manage stress and maintain resilience. They are trained to develop what psychologists call self-efficacy, the belief in their own ability to achieve goals and overcome challenges without immediate external support. A final unique aspect of astronaut teaching and learning is how to problem solve with international colleagues using cutting-edge technologies. Astronauts must learn to communicate and work with colleagues from around the world, so they undergo intensive language training to ensure seamless cooperation with other astronauts. This cultural and linguistic adaptation is as crucial as any technical skill. The ability to work fluidly in multicultural teams with diverse work styles is critical to the success of the international missions aboard the ISS. Additionally, astronaut learning embodies Kolb's experiential learning theory. Astronauts learn through a continuous cycle of experience, reflection, conceptualization, and experimentation. Space technology constantly evolves, and astronauts must update their knowledge and skills to adapt to new systems and protocols. They engage in hands-on training, mastering new space station systems, upgrading their understanding of robotics, and refining their language skills for effective communication with international partners. An excellent example of this is astronaut Peggy Whitson, who holds the record for the longest cumulative time spent in space by any American astronaut, 665 days. Over her many missions, Whitson's adaptability and commitment to experiential learning were vital. She cycled through the stages of Kolb's model, repeatedly training and retraining on systems and protocols as technology advanced. Her ability to reflect, adapt, and experiment enabled her to perform tasks ranging from conducting critical spacewalks to troubleshooting advanced space station systems. For astronauts like Whitson, experiential learning isn't just a method, it's essential for survival and success in space. Thanks for watching. If you enjoyed learning about how astronauts adapt and grow through hands-on training and problem solving, be sure to hit the like button and subscribe for more insights into how different professions teach and learn in unique ways. See you next time.